Very good afternoon to everyone. I welcome all the dignitaries and the participants present here. We will have a webinar on post-production precautions of concrete by the engineer V.R. Kaushika. I, Begum Tabani Zia, stand before you as a proud student president of the American Concrete Institute. Today's webinar marks a crucial step in our academic and professional journey as we delve into the realm of post-production precautions in concrete construction. On stage, we honor the head of the department in civil and environmental engineering, a mentor whose commitment elevates our learning experience. I'd like to invite Professor S.S. Mahanti, Sir, head of the department in civil and environmental engineering, to kindly come forward and share their insights with us.
Good afternoon to all. And all my colleagues, and I welcome Engineer V.R. Kaushika, the Director of QCrete Concrete Readymix QCrete India Private Limited, Bangalore. And this is the first webinar to be organized by the student chapter of ACI, American Concrete Institute India chapter, and this CGU student chapter. This is the first one to start with, and they have gotten field visit on 20th, maybe today is the 25th, 5 days before. So they have their exposure and experience, how the professionals are now working in the field, taking care of whole construction and the logistics. When I say logistics, I'm not talking of safety measures only. I'm talking of each and every activity which help to have a best practices in having concrete is one of the important construction material to be used for construction industries. And here, this is the first webinar to be presented by our esteemed guest, Mr. Kaushika. To take care of, concrete is the one that you will be putting in the intended portions or section of a structure you are supposed to construct. And before it is put there, and in between there is a loss of time from the production center, generally basic plant, to the laying spot, the laying section. In between, those what are the cares that are supposed to be taken care of, not to minimize or keeping the standards you expect while you are doing the design mix, your structure or the site, the member that you are constructing are getting on. So I welcome Mr. Kaushika here and all the student members of second year, third year, and final year students, and the members of the functionaries, president, secretary, treasurer, vice president, and the committee who assists support people to come in such a large, small gap of time, an event after 4 or 5 days, another event. I thank you all that you go ahead, keep it up. Thank you. Thank you all.
Thank you, sir, for sharing your insights with us. Today we have the privilege of welcoming a distinguished member of our faculty to the stage. Without further ado, let's extend a warm welcome to Dr. G. Sridevi ma'am for their insightful address. Please join me in giving them a round of applause.
Good afternoon, everyone. My hearty welcome to Engineer V.R. Kaushika, Director QCrete India Private Limited. Sir has already given us one or two webinars. I know the quality of presentation what he is going to share. Sir, I welcome you, sir. And my hearty welcome to our beloved HOD, my colleagues, and student members of American Concrete Institute. Now, this year we have started another chapter, Indian Geotechnical Society. This American Concrete Institute is existing well before my joining this institute.
Hello.
And it is doing extremely well, American Concrete Institute. Academics are everywhere present, but beyond the academics, civil engineers especially require life skills. And this kind of professional societies, they help us to acquire these life skills which are needed very much. So by starting this American Concrete Institute, by organizing events, we are hoping that our students will be learning all these life skills like leadership qualities, then collaboration, then communicating with others, and all other required skills. Today we have with us engineer V.R. Kaushika, who is going to talk about post-production precautions of concrete. Once concrete is produced, now we expect the concrete to have strength, longevity, and durability. Now, in order to protect all these things, what precautions we need to take once the concrete is produced? So today we have with us speaking about all these aspects. Thank you very much, sir, for accepting our invitation and giving this wonderful presentation. Thank you very much.
Thank you, ma'am, for sharing your insights with us. Next, I'd like to invite Dr. B.P. Mishra, sir, for profile readout, whose teaching style strikes a perfect balance between challenge and guidance.
For that wonderful introduction of mine. Now it gives me immense pleasure to read out the profile of today's speaker. So, V.R. Kaushika sir, he did his B in civil engineering from University of Mysore in 1990. Thereafter, he worked as a site engineer for Property Development Corporation from 1990 to September 1991. Thereafter, he joined Phosphate Chemicals as application engineer, and he worked there for almost 3 years. Post that, he went to SM Supplements India Limited, which deals with construction chemicals again. He worked there as an assistant manager in marketing and technical services. Thereafter, he worked as a territory manager for BAM Organic Chemicals Limited, which also deals with construction chemicals. Followed by, he also worked as a technical manager and sales manager at RMC Readymix India Private Limited. Following that, he worked as a company technologist for Master Builders Technology, which is in Kingdom of Saudi Arabia. Apart from that, in Oman, he has also worked for Al Turki Cement Products in Oman as a QA/QC manager. Presently, he is working as the director of QCrete Readymix India Private Limited from July 2019. Along with this, he is the Executive Director of QCrete Private Limited. Mr. Kaushika has published articles on concrete related topics, and he gives regular lectures on National Council for Building Materials, Hyderabad, Engineering Staff College of India, and many other engineering colleges. So also he has done external RMC MA audits as well. So with this brief introduction of almost about 33 years of experience, I welcome Mr. Kaushika sir to please share his presentation. Sir, please.
Good afternoon. Can I start? Thanks for the introduction. And thank you all, the organizers, ACI, CV Raman, Global Academy, Orissa Bhubaneswar, and HOD, Principal of the college, and my special thanks to Dr. Sridevi Madam for inviting me for this webinar. I'm thankful to all of you for giving me this opportunity to speak to you all. And I hope at the end of the session, students will gain something out of this webinar. Most important thing which I want to speak today is what we are going to do after production of concrete. You have a batching plant in a ready-mix company, or you have small mixers. You produce concrete in that, and what you are going to do after that, how you have to take care of this. That is what we are going to discuss today, and what precautions we have to take. And this includes two categories of experience. One is what actually you are going to do with concrete after production, how you are going to check the quality of this concrete, etc., which is so what precautions we have to take. That's what I'm going to talk. As I said, it will have two categories. One is what we are going to do actually with the concrete after the production, and then secondly, once it is placed in position in an element, in structure, what precautions we have to take. These two things I'm trying to speak in this. So I always talk about the most oldest structures and the biggest structures which are available on this earth, which is pyramids of Giza in Cairo. Why I talk about is the beauty of these structures is the planning that has been done 5,000 years back or 6,000 years back, whatever it is, and the alignment and the methodology that they have applied, so on and so forth. These pyramids are said to be most scientifically designed and built structures ever on this planet. To the best of our ability, until now, the methodology is not known how these structures have been built. What intrigues us is the quality control applied from planning stage to execution stage to protection of these, which have made these structures stand the test of time for such a long period of time, 5,000 years. So what I bring here is when we are constructing structures with RCC, which is basically steel embedded in concrete. We need to apply our knowledge given in civil engineering um, during our studies, etc., and execute to the best of our ability so that they can be durable and people will speak of it, and we are proud of that kind of structures actually. So this is a classic example of how post production techniques are also applied here. Means some technology to preserve the structure, how the structures was finished, all this stands out and stands the test of time. So similarly, when we are doing concrete, we should also look at how we are going to handle the concrete. Even though these pyramids have been built with sandstones, um, limestones of huge weight, 2 to 75 tons of each one weighs 2 to 75 tons, and it is said that more than 3 to 4 million blocks have been used actually. We can imagine the amount of work that they have put actually. So post production techniques after the entire construction has happened, how they have checked and how they have rectified any mistakes and all is important. Similarly, when we do a structure, when we finish concreting, what are the things that we have to look into during the concreting, placing, and then finishing? All these things we need to consider. Similarly, there are classical examples, many examples. Thousands of years ago, in Peru, these structures are being built. In India, a lot of temples are there. We will be all wondering how these people have built massive temples. If you go to Tamil Nadu, you can see a lot of huge temples built, architecturally pleasing temples actually, which have stood the test of time again. So all this involves a lot of planning, execution, reviewing, and any corrections. If there is any correction has to be done, they have done it actually. So these things have to be. These are the principles which have to be applied, whether it is concrete, whether it is construction, or whether we are producing any other thing, whether it is bakery also, same principles actually. So in concrete, we have three sections. One is forward control, which is set of all activities that we do before production of concrete. Immediate control, which is set of all activities that we do at the point of production. And then the last one is retrospective control, which is the set of all activities that we do after the production of concrete is done. So these three aspects apply to anything, whether you are doing construction, whether you are doing any production, any even if you go to mechanical industry also, or any industry for that matter, same principles are applied: forward control, immediate control, and retrospective control. And today's lecture is basically on what we do on the after the production, that is retrospective control. So in civil engineering, as I'm talking to most of the students, all these structures, including the most modern structure as on today, which is Burj Khalifa, all have one thing in common. This is built by people who have passion and with intelligence, management of information, and ability to work in groups. So as civil engineers, if we want to produce concrete and long lasting structures, we should have these things as our basic principles. We should have passion to make good structure, durable structure, and proper management of information, and intelligently managing the information, and ability to collaborate in groups and work in groups. That is a basic foundation for any civil engineer, especially when you are growing in the management, or when you grow up as a manager. So Coming back to concrete, once the concrete is produced in the batching plant, there are several aspects which we have to consider before we go to placing and curing and consolidating and things like that, which are equally important, which are most important. Before we go on to that stage, what is the measure that the concrete is good actually? What is how we are going to tell that the concrete which is produced is good? So IS 4926 very clearly defines how you have to take the sample actually. So the when the concrete truck arrives on site, 1/3 of the first cubic meter has to be dumped actually into the structure or into the pump, and then you have to take the concrete after mixing thoroughly actually. So this is a method which is clearly defined in IS 4926, but BS has a BS has a better way of defining this actually. BS has a BS code IA BS 1881 has a better way of defining this one and better way of doing this one actually, where 1 cubic meter from the concrete truck is left or dumped onto the pump actually, and then the scoop moves at vertically when the concrete is falling like this from the chute of the truck. The scoop moves, and then the concrete is collected in 4 or 5 parts actually from the 6 meter cube. Means first cubic meter is left, last cubic meter is left, and from the remaining cubic meters or remaining volume, the concrete is collected. This is how the sampling has to be done. Why we are talking about this one is, if you don't take the sample in a specified way, in a proper way, so you may end up with a wrong sampling actually. You may end up with a wrong sampling, unmixed sampling. The truck has to be turning, and then the concrete has to fall continuously. From there, you have to take this collection. You have to collect these sample in 4 or 5 scoops as required for casting the cubes actually. So from you have to leave the first part, you have to leave the last part, and then you have to take the concrete sample from the remaining parts. Same thing is defined in the ASTM standard, that is ASTM C96, which talks about the sampling and how you have to do the concrete production in a ready-mix company. So this is very important. What you are doing with the concrete once the concrete is produced, how you are taking the sample. So this is an example here. The concrete is falling from the truck like this, and the scoop has to move like this in a vertical, means that perpendicular to the movement of the concrete flow. So this has to be done like this actually. Okay. So for every somebody may ask this question, why we have to do like this? It is a standard procedure for everything in the world. For every product in the world, there is a certain way of taking sample. Okay, whether you are taking sample of aggregates for testing, whether you're taking sample for example, you are going to a site, you want to check the SPC of soil, how the soil sample has to be taken. All these procedures are defined, and it has to be done like that. Then you have slump test actually, and then here you can see, when you are making concrete, the mix has to be cohesive actually. So you can check when the concrete has been produced and it has reached your site. You can check whether the concrete is cohesive, means it should be like we used to tell in the earlier days, in the 1990s to 2000 we used to tell. Now also we talk like this. It has to be like, like curd rice actually. Like if you take some concrete on hand, if you squeeze, the water should not separate actually. Water should not separate, and mix has to be, then it can be pumpable actually. So IS defines properly how you have to do slump test actually. You might have all done how to this procedure. In this slump cone, you have to take 4 layers, each 15 layer, 3 layers, each layer 25 strokes each, and then when you lift the cone, how much it falls, that is referred to as slump. This is the best slump, that is true. It shows a cohesive good mix. This is this represents a collapsed concrete, which is free flow concrete. And then shear, it should not have a shear in at a slant, it should not fall like this. So these are some tests which will indicate the quality of concrete when you are receiving at site. Actually, this has to be seen, actually this has to be observed. Now we have moved to what is called as self-compacting concrete. All of you may be aware of the fact that self-compacting concrete was first introduced by Okumura of Japan in 1986, and from 1986, especially through 1990 onwards, uh, 2000 to 2010, it has moved well and it has become popular. So self-compacting concrete is a concrete which consolidates by itself. Actually, there is no vibration required. Actually, so it levels by itself by water, like just like water, and you can see how the flow takes place. This is called a flow test. Actually, this is not a slump test, and you can see how the mix looks cohesive. Actually, there should not be bleeding here. These are the things that you have to observe when you are receiving the concrete. That's what I am talking about. Precautions that you have to take after you produce the concrete and receive the concrete. You can see here there is no bleeding, there is no separation of water. So that is the beauty of such concrete. It has to be designed in a proper way. So there are several tests, actually, like self-compacting concrete is not a simple concrete. It has several, it has to exhibit several properties. One of these is a YouTube test, actually, where you fill the concrete here. There is a shutter here. Once you lift the shutter, the level has to be similar, actually, just like water. Both the limbs, this limb A, limb B, or leg A, leg B, both has to be in the same level, actually. Okay. So if the difference is more than 30 mm, it is rejectable. So the level here and level here, if the difference is more than 30 mm, this is rejectable. Similarly, there is L box test. Okay, you fill up the concrete here and you lift this shutter. The how much it fills up. This height to this height ratio should be between 0.8 to 1. So this is called a L box test. There is a V funnel test also, where you fill up the concrete here and you remove the shutter here or open the shutter here. This has to be collected in 8 to 12 seconds. Within 8 to 12 seconds, normally it has to be collected, actually. So if this takes more time, then this concrete is not a self-compacting concrete. So that is how these concretes are checked, actually, once it reaches the site or before using. To check the quality of concrete, the most important fundamental and decisive test, what we can say, is the compressive strength. Most of the ready-mix producers and most of the clients take this as the one final test for ascertaining the quality of concrete. And we can say this is the most neglected portion of quality control post production of concrete, actually. So many times what happens is somebody comes, just he fills up and goes, and your concrete is judged based on some random way of filling up the concrete. So what we need to do is, it should be, if you take a 150 mm by 150 mm by 150 mm cubes, it has to be filled up in 3 layers. Each layer minimum 35 strokes each, as per the IS code. We have to tamp like that. And when you are tamping the first layer, second layer, just the rod has to touch the first layer. So like this, you have to follow certain procedure. Everywhere we have to follow a proper procedure, and these cubes have to be stored properly before it is moved to curing tank or curing. It has to be protected by polythene sheet so that evaporation does not take place. So these are the some precautions we have to take. If you simply don't follow this procedure of making the cubes properly, you will get results which may put you in a quandary whether to accept this result or whether the concrete is good or bad, something like that. So we need to follow a proper procedure. Okay, so this is a elaboration of the same. This is the elaboration of the same. How we have to cast the cubes, etc. Workability, as we have checked, as we have already talked about, workability is one of the major parameters that is checked. Earlier, it was slump. As per IS 4926, if the slump required is X, that is, for example, you require a slump of 100 on site, the allowed as per IS is plus or minus 25 or one third, whichever is smaller. So, for example, if you want a slump of 100 means you can accept the slump at 75 or 125 or one third, whichever is smaller. So we need to see, for example, you have got the truck coming to your site. Truck has come, but you need to check whether you have at the production facility is like this or not. If the production facility is like this, it indicates chaotic situation where the quality control may be a question mark actually. So you need to think just by seeing the concrete, it may not be good actually. It may not be acceptable. You should also see what is happening in the batching plan. So as we talked about earlier, now you have sampling of concrete on site, which we have to do, testing, monitoring. These things are important actually. And then you need to also sometimes randomly check the yield of concrete actually. Yield of concrete is how much, whether we are getting 1 cubic meter of concrete or not. So whether the concrete which is produced by the manufacturer, he says 6 cubic meters, whether it is really 6 cubic meters or not, there are tests actually defined in 1199, PS 1199 that you have to see. And we need to monitor once you receive this on the site. We need to check whether, for example, 400 kgs of cement is there in a mix, whether 400 kgs is really gone into the concrete or not, that we need to check. So, for example, you are given an order for 1000 cubic meters, whether they have utilized 1000 into 400 kgs or not, we need to check by that can be checked and ascertained by stock control of materials. And if there is any complaint, say for example something is happening, you need to tell to the to producer, and based on that one, the Readymix company or the producer will change the mix design or something like that. Analysis of cube results and statistical analysis is important actually. Say for example, concrete is produced, it has come to the site, you have sampled, and whether the results are okay or not, that feedback has to be given. Based on this feedback, you will allow the ready mix company or the producer to improve upon or change or meet your requirements in a proper way. This is all post production techniques of quality control. So at site, what you have to do once the concrete comes, most importantly, you need to check what is the time of batching. As per IS code, once the concrete is mixed, cement comes in contact with water, it has to be used between 2 to 3 hours. IS code strictly says it can be 2 hours, and you can increase that one only if you are using a super plasticizer or you are doing concrete in winter cold conditions. So You cannot use the concrete which is batched at morning 8 o'clock in the evening, maybe 6 o'clock. 6 hours, 7 hours, and all you cannot use. So, time of batching is very important. You need to check time of batching. This is all available in the on the batch sheet. Most importantly, in for concrete, after the concrete is produced, it comes to the site. We need to check whether the right water cement ratio is used or not. So, what is the importance of water cement ratio? Water cement ratio is the one which governs all the engineering properties of concrete. The strength and durability of concrete is directly dependent on the water cement ratio. The strength of concrete is said to be inversely proportional to water cement ratio. The strength of concrete is inversely proportional to water cement ratio. So as the water cement ratio increases, the strength decreases. You need to also know another point, that as the water cement ratio increases, permeability also increases. So you have a huge problem. You have two problems. One is it affects the strength, and another one, it affects the permeability. As the water cement ratio moves up, permeability goes up, means the concrete which you have batched will not be waterproof, will not be waterproof. So the waterproofness of concrete or impermeability of concrete is dependent on the water cement ratio. More the water cement ratio, lesser the strength, and more the water cement ratio, lesser the durability. Hence, we need to check what is the water cement ratio, whether the producer has used the right water cement ratio as specified. So this is very, very important post production precaution that you have to take, whether it has come at right slump or not. And as we discussed earlier, you cannot use the concrete beyond 3.5 hours. Let us say the concrete has been batched at about 8 o'clock in the morning. You can use maybe 3 hours, 3.5 hours generally, unless otherwise it is established that you have used a very special admixture, very good admixture, which can give a slump retention of 4 to 5 hours or 6 hours like this. There is also a cap on the batching tolerances. Okay, we need to check after the concrete is produced, when you are receiving the concrete, whether the batching tolerances are there. For example, in IS 4926, it is very clearly defined. Cement or cementitious metals have a tolerance of plus or minus 2. The other metals like aggregate, coarse aggregate, fine aggregate, water has a tolerance of plus or minus uh, 3%. Plus or minus 3% should be the tolerances. So these tolerances have to be checked right. These tolerances have to be checked right when you are receiving the concrete after the concrete is produced in a batching plant. So what happens if the concrete is stuck in a traffic jam? For example, in any of the Indian cities, you have traffic jams nowadays, and fully crowded ways actually. So a concrete is designed to reach the site. The concrete is designed to reach the site in half an hour, but it is stuck in a traffic jam. What should we do? If the slump is less, we can add chemical admixture on site. You can add a superplasticizer on site and bring it to a pumpable or placeable level. So this is possible as per ACA 2124R and IS 4926. But there is a caution. What is the caution that you have to take is you cannot go on adding chemical admixture. 2 times you can rejuvenate the concrete. The concrete is produced, it comes to your site, you find the slump is less, and the time is about 2.5 hours. You can use it for another 1 hour, but you cannot use directly because the slump is less. In that case, you add about zero point 0.1 to 0.2 or 0.15% of chemical admixture, diluted in water, 5 to 10 liters of water, put it back of the truck and then mix it, remix it and use it actually. So you cannot do this operation more than 2 times actually. Okay. So what are the other things that will happen once the production happens and it reaches the site? More water, slump may be more. If the slump is more, we discussed about slump is less. What we have to do? If the slump is more, then it may be because of higher water cement ratio, which will lead to lesser strength. There may be coarser materials, 20 mm, 12 mm sand, maybe coarser, then it may be a problem. In that case, also you might have had a higher slump. More chemical admixture might have gone. Then sometimes it may lead to setting time problems. Wrong batching might have happened actually. So maybe lesser ingredients. Then also it is a problem. A different cement or same cement brand with different properties. Then also the slump may be more. Check before accepting. Check all these details. Sometimes you can ask the Readymix concrete company to certify the batch, guarantee the batch. So this is how you have to look at the concrete which when it comes to site actually before you start placing the concrete or accepting the concrete. So some of the information which a producer is supposed to give to the uh, user. For example, as engineers, you start project, you start constructing an apartment or a public building or whatever it is, then you have the right to ask the ready-mix manufacturer whether it is a captive plant. Captive plant is a plant which is there on your site actually. On the other hand, a commercial ready-mix plant can be somewhere, it travels for 20 kilometers, 10 kilometers, comes to your site. So in that case, the Readymix company is supposed to give all this information. The information is what are the sources of all the ingredients. Each and every ingredient what has been used is supposed to, the producer has to give. Source of supply of cement, what kind of cement has been used. You know, there is a OPC, there is a PPC, there is a PSC. So what brand of cement and what kind of cement is used, the producer has to give. And mixed proportions, whether the mixed design has been submitted. Mixed design is submitted before to the production stage, before you start ordering the concrete. Along with the purchase order it will go, so you can check through the batching slip whether the same mixed proportions are used after production. For example, you have given a water cement ratio of not more than 0.4 for a particular structure, especially let us say you are making a foundation, you have specified maximum water cement ratio 0.4. So, and the mixed design has been submitted by the concrete producer. So you have to check all the ingredients and proportions whether it is as per the accepted mixed design which is submitted earlier, right? And then the producer has to also give information on generic types of main constituents of admixtures. What kind of chemical admixture it is, whether it is a super plasticizer, you have different kinds of super plasticizer. You have a PC based admixture, high end PC based admixture. Nowadays, we are getting PC based admixtures which can give 40% water reduction. 40 to 45% water reduction is possible. So this kind of information has to be given by the producer, concrete producer. It is not that just he sends the concrete to you, and you need not have to accept unless all this information is given to you. And then whether the dosage is properly done, whether the dosage causes air entrainment, means sometimes you see a lot of air bubbles in the concrete. That shows compatibility. What is compatibility? Compatibility means, for example, you have a particular brand of cement and you have used a particular kind of admixture. So the slump will be very high with this admixture at a particular dosage, or very low with this particular admixture, or it may have setting time problem, or it may give more air. These kind of things can occur. Actually, these kind of things can occur. Okay, so 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 these things have to be told. These things have to be clearly specified, and that has to be executed. And as a receiver of concrete, as a receiver of concrete, the engineer on site, the project manager on site, and the quality control person on site have all the rights to check these things. Check these things before the concrete is accepted. So you have the full checklist. You should have full checklist of what you have to check when the concrete comes to your site. Post production. Post production. What are the things that you have to check? Material should be as per IS 456/2000. Okay. So does that mean anything? Any product which is not as per IS 456/2000 should not be used? It is not like that. For example, you have a ASTM standard. You have a BS standard. There were, for example, uh, for GGBS, which is used extensively in India. Earlier, there was no code in India. After 5 years or 10 years of usage in India, it is used. Earlier, American standard was used. So either IS 456/2000 or Indian standard, or any approved international standard, whether the product is as per that one or not, we have to check. And material testing and all has to be completely defined. Means what is the frequency of testing, what is the testing of cement, all these things has to be defined, all these things has to be given to the customer. Calibration of batching plant is done or not. So you have the right. For example, the concrete comes to your site, you can always ask the question any point of time whether the concrete is batched properly, whether the calibration is done. Do you have the document to show that the batching plant is calibrated? If the concrete truck is not maintained, for example, there is a leakage in the water pipe, which generally is used by the ready-mix companies for washing the trucks after delivering the concrete, or washing the chute or something like that. So if this water tap is leaking, it is adding water to the concrete. So these things have to be checked actually. Whether the whether the lab has all the calibration done, whether the calibration is happening in batching plant, checks are happening in batching plant, like moisture is a very very important thing before production. Whether the moisture is applied or not, this is reflected in the batching slip actually. When you get when the concrete reaches to you, you have moisture content on the batching slip. So whether how much is the moisture content used, and what is the moisture content on the sand on that day, all this have to be checked actually. And then you have the check set site, which we discussed again about time of this one, time of batching, all these things which we need to do. Now, coming to the major portion of our discussion. Well, as I said, it has our discussion today has two parts. One is the how you are treating the concrete after the production, how you are receiving the concrete post production, what are the precautions that you have to take before you accept the concrete. This is the first part. The second part, which is important, again, equally important is after receiving the concrete, accepting the concrete, how you are going to place the concrete. For example, you are placing by pump. The concrete is pumped onto the slab, pumped onto the columns. So this should not fall from a very high height, very long distance to the element that you are receiving actually. So earlier the distance was 3 meters, 3.5 meters. The concrete should not fall. So then the Readymix companies made this trimmies actually. So you design like a funnel, and through the funnel the concrete falls actually. So it is very important that the concrete should not fall from a very high height, very big altitude. If that happens, then segregation takes place. Concrete segregates, aggregates will be different at a different place, sand will be a different place, cohesion will be lost, and then the concrete will not be uniform. So the height of the height from which it falls or it is pumped is also important. You have to be cautious about this. We need to see that whatever height you decide, whatever you do, the concrete when it is put on the element or placed on the element, it should not have segregation. Okay. Now comes vibrating. So once the concrete is placed through any method, some people use chute directly onto the slab, some people use pump, and some people use skip bucket. Means you have small buckets carrying the concrete onto different floors. Whatever method you use for placing the concrete, once the concrete is placed, the concrete has to be vibrated. Why the concrete has to be vibrated? Because if you don't vibrate the concrete, it will not get consolidated. If it does not get consolidated, there will be air bubbles in the body of concrete. So the idea of vibration is to remove the air bubbles from the body of concrete, which is trapped during production. Some amount of air is always trapped during the concrete production, and that has to be removed. That is the main purpose of doing vibration. So you have different kinds of vibrators which are called as poker vibrators, which are generally needle vibrators. You dip this into the concrete, and then concrete gets vibrated, or the air bubbles come out actually. So when you are using these poker vibrators or needle vibrators, these have to be dipped vertically actually. The needle vibrators have to be dipped vertically into the concrete, and you should not vibrate more than 10 to 15 seconds. You cannot go on vibrating the concrete for a long time. You have to use about 5 to 15 seconds, not more than 15-20 seconds. Okay. And then there is a spacing. For example, you have done the vibration in one spot. The next spot you select in such a way that it can be approximately 150 mm to maximum 200 mm. And when you are dipping this vibration needle, there is a radius of operation. So it vibrates the concrete in a certain radius actually. So when you are dipping next to that one at about 150 mm or 170 mm or 160 mm, whatever it is, there should be overlapping of this vibration. Means you can see the first radial overlapping with the second radial. Like this, the concrete has to be vibrated. You cannot space these as you want. It has to be spaced properly. And then when you are removing the vibrating needle, it has to be removed slowly, like 1 inch or 1.5 inch per 1.5 to 2 seconds. Quickly you should not, and in the same way, you should not remove very slowly also. And when you are vibrating this concrete, when you are vibrating the second layer, it should just touch the first layer. This is how the concrete and concrete has to be vibrated actually. So what happens if you are not doing vibration properly is if you are doing under vibration, means if you are not doing vibration properly, the labor or many times tired in the end of the day, they don't vibrate. What happens? It may lead to honeycombing, it may lead to segregation. So many of these kind of problems can occur and lead to durability issues. In the same way, if it is over vibrated, if we go on, somebody is going on vibrating the concrete, what happens? All the lighter materials, which is cement and sand, will come up, slurry will come up, the surface will become weaker, there may be more air voids sometimes or less air voids, and then there will be sand streaks. What is called as sand streaks means lines created by sand movement, because sand is lighter than the coarse aggregates, so sand will move up and down. It will create what is called as sand streaks. So these are some issues which occur if you don't vibrate properly. Vibration is very, very important. As we know, if air voids are left in the body of concrete, honeycombing is formed in the concrete because of under compaction. It will lead to lesser strength. It will lead to lesser strength. Next is curing. Curing is the most important aspect, which is many times neglected. So, what is the you can say what is why curing is required? Curing is required because it is a method of holding sufficient water in the body of concrete so that hydration takes place continuously in the body of concrete. That means to say that if you have mixed about 160 liters of water into the body of concrete as per your mix design, some evaporation will take place. You cannot stop the completely evaporation, but maximum amount of this 160 liters, which is called free water, should be available for cement to undergo hydration. So if there is quick evaporation from the body of concrete, then it will leave what is called as capillary pores in the body of concrete, leading to porous nature of concrete and drop of strength or lesser strength. So curing is a method of keeping the concrete cooler so that evaporation losses are reduced and sufficient water is available to the concrete for cement to undergo proper hydration, and hence this is a way of achieving the designed strength. Curing, there are several methods. The simplest method is as soon as the concrete is placed, you sprinkle water on top, keep the concrete cool, then you do ponding, water ponding of concrete. Next, you can do polythene sheeting. You envelop the entire concrete surface with polythene sheeting, and the next method is spraying or brushing or coating of chemical curing compound. The latest methodology or latest technology is integral curing compounds. So these integral curing compounds are added along with the concrete manufacturing. When you are making concrete, just like another admixture, this is added to the body of concrete, and this does the job of curing. So curing is very important. Intermittent curing is bad, means you start curing today and then you stop for some time, and then you again start another day. This kind of intermittent curing is said to be bad. So curing has a very enormous effect on the strength gain. We'll discuss again on this. The other most important aspect is handling of concrete cracks. Uh, Concrete has a tendency to crack. Why tendency to crack is concrete is weak in tension, and concrete shrinks actually. Any material shrinks because of the temperature variation. So concrete also shrinks and expands actually. So basically, after the concrete is placed, as soon as the concrete is placed, the operational losses are maximum actually. So because a lot of water is available at that point of time, lot of evaporation takes place. So minimizing the evaporational losses by curing, initial curing is one of the best methods to reduce the initial cracks, which are classified under two headings. One is plastic shrinkage crack, another is plastic settlement cracks. So these two cracks can be avoided to a larger extent or a great extent by initial curing, by usage of proper curing methods, and sometimes it may be very, I can say, impossible to stop cracking because of the external factors. The external factors which influence concrete cracking, especially in the initial stages, is high temperature, which leads to high rates of evaporation, high wind velocity, which leads to sucking of water from the surface, and then low humidity, which again leads to osmotic evaporation of water and concrete giving away water to the atmosphere and loss of water. So when something is lost means when water is lost quickly, like due to evaporation of water, so that unfilled portion appears like a crack. So you need to handle the crack. So to avoid the crack, there are very simple methods. You start early curing, proper curing, and then you observe the concrete, and then you protect the concrete against winds. Do the concrete in evening time or the colder time when the temperatures are low. If the cracks appear, then you have to retamp the concrete or revibrate the concrete. So this is a simple technology which is very clearly mentioned in, if you go and see this document, which is a very, I can say, one of the most authentic documents on cracks is uh, technical note number 22, um, given by Concrete Society. So this is one of the most wonderful document on the cracks actually. So cracks happen in concrete post production when you are placing the concrete, and we need to take care by proper curing, which is generally people carry like a water in a pesticide sprayer and start spraying as soon as the concrete is placed and compacted within about 1.5 hours, and you have these cracks coming up, especially if you have very high structures. For example, you have very high structures, 30th floor, 25th floor, and all. Uh, you will experience in future when you stand on 25th or 30th floor as an engineer, you cannot stand because of the wind. So much high winds are there at that level. Actually, very high velocity winds are there. So standing itself is difficult sometimes. Okay. So in that case, it will take away water from the surface of concrete. So we need to protect the entire slab before we start concreting by polythene sheeting or by tenting or shading. And then together with that one, if cracks appear because of high winds or high temperature or low humidity, you have to retamp the concrete. This is very clearly defined in technical note number 22, Concrete Society. Okay. So these are some of the precautions that we have to take. Protecting the concrete. After all this is done, you have waterproofing experts, which they suggest how to protect the concrete actually. You have additives which can reduce the shrinkage in the long term and short term. Good additives are there, which increase the durability, which reduces the shrinkage. You have fibers, microfibers, and macrofibers, especially small uh, microfibers made up of polypropylene or polyester fibers, which can be mixed with concrete and which reduces the cracks. So these are some of the methods to reduce the cracks, along with what we discussed earlier. And then the final protection comes from protective coatings or waterproofing coatings. Many people think wrongly that once the concrete is placed, best concrete is produced in sent from a Readymix company, placed on the roof slab, job is over. No, you have to protect the concrete by using suitable waterproofing methods. Concrete itself is not waterproof. No matter what you do, there will be some blemishes. Somewhere somebody has not compacted properly, or some honeycombing may come, some defects may come because of so many reasons. Defects can also come because of a poor shuttering. If you have a poor shuttering, improper shuttering done, and if you have not applied oil properly, for example, there are shuttering agents which have to be which are also popularly called as mold release agents. If they are not applied properly, when you de-shutter, there will be some blemish, some surface defects in the concrete that may lead to leakage. That may not make the concrete waterproof. So there are many issues because of which waterproofing problems may come. So the concrete has to be protected against the attack by sulfates, chlorides, water, oxygen, carbon dioxide. So we need to use protective coatings, waterproofing coatings, systems and all, which are basic actually. So in India, many times it is neglected, but otherwise in other countries, these are all taken to the minutest detail. So some of the precautions we have discussed here today, I feel the what I have shared is useful, and somebody can ask question. Anybody who wants to ask question, you can ask question. So sorry, I have something more. I forgot actually. So curing has to be done at 27 plus or minus 2 degrees. When you are curing the cubes, actually cubes have been transported and cured in proper tanks, which is the curing tank, and the curing water should be at 27 plus or minus 2 degrees. We need to know, this is very important for people who are in site actually, who are going to be working in site as project managers or site engineers or something like that. So concrete, once the concrete is produced, post concrete production, if you make sampling error, there may be difference in strength which can move up and down. Failure to remix the sample, if you don't remix the sample properly, cube molds, if it is bad, then it can be negative up to an extent of 20%. Incomplete compaction, we already discussed about compaction. Every 1% of uncompacted concrete will lead to 5% loss in strength. Temperature outside the permitted range. Permitted range is 27 plus or minus 2 degrees. So if the concrete is, I'm talking about cubes, if we cure the cubes outside this range, you will get a different strength. So what should we do when you are talking about concrete slabs or concrete columns? The concrete columns or concrete slabs have to be kept cool. It has to be wrapped with Hessian cloth or polythene sheets, continuously cured to keep the concrete surface cooler, so that evaporation losses will be lesser. Otherwise, the concrete will not reach the designed potential strength which it should reach actually. Continuous curing, as we have discussed. Cube location means how you are testing cubes, whether the calibration of cube is done or not. All these things are important. So post production, when you are receiving, handling concrete, curing, compaction, and monitoring the cube strength, how you are casting the cubes, all these things play an important role. Okay. So I think with this, we are I'm ending my presentation. Any questions are there? You can ask.
Sir, I have one question.
Yes.
Suppose we are working in extreme weather conditions. You said if temperature is very high and wind velocity is high, what precautions we need to take? In the similar manner, if the temperature is too low, then what precautions we should be taking to see that concrete is durable?
For example, the best concrete properties are achieved when the concrete is produced at 20 degrees. They say the concrete has to be produced at as low temperature as possible, but if you are going down towards 4 degrees, 5 degrees, below 6 degrees, then water tends to become ice actually. So then it will crack the concrete. So in many times in colder countries, if anti-freezing admixtures are used, where the water should be in the liquid condition, and then secondly they heat the aggregates. They heat the aggregates so that the aggregates are kept at a normal temperature level, means around 20 degrees or 15 degrees, where the water does not freeze. You know, if that happens, then it will leave pockets of ice in the body of concrete, and durability, especially with respect to freeze thaw, will be affecting the concrete. So in cold countries, like for example, uh, like in countries like Russia and all, they use this what is called as heating actually. They heat the water, they use warm water, they heat the aggregates also sometimes if the concrete, if the temperature is very cold actually, and then use the produce the concrete actually. Otherwise, the concrete will not flow. Concrete will have lot of icy structures which will damage this concrete later. So heating is one of the methods adopted actually. Yes. Yes.
Thank you, sir. Thank you.
Thank you.
A very good afternoon, everyone. I am Subham Kumar, standing in front of you as a proud student of Secretary of ICACI Student Chapter CGU. On behalf of all the students and faculty members, I am pleased to propose a vote of thanks on this occasion. First and foremost, a special thanks to our chief guest, Engineer VR Kosika. Please give a big round of applause for his efforts. Thank you, everyone. Sir, your presence has truly elevated the learning experience for all the participants. We express our gratitude for your time and knowledge. Next, I would like to thank our guest and HOD sir and Sri ma'am and all the faculty members. Then next, I thank to all each and every present here. Finally, I leave you this inspiring quote by the Dalai Lama. The root of all the goodness lies in the soil of appreciation. Thank you once again. Thank you. Thank you, sir.
Thank you. Thanks once again to Dr. Sanjay Verma and Dr. Sridevi Madam, and thanks for all the people of Dr. C.V. Raman Global College.